Hi everyone, I am Dr. A. Muriesan, Department of Biomedical Engineering from KSR College of Engineering. So, in this video, we discuss about the CAN bus. So, CAN is the Controller Area Network. It's mainly used to communication between the devices used in the automobiles, and especially in cars. We have a dashboard. The dashboard consists of all the controllers. It, it will indicate the lighting, power windows, and status of power seats, and it also indicates the engine control, transmission control, then active suspension, anti-lock brakes, and airbags, and the air conditions and power locks. So these are all the controllers, electronically controlled devices nowadays. So these all electronic controlled devices are connected to the dashboard. So you need the communication between the dashboard with the electronic system inside the automobile. So for that we need a protocol that is called Communication Area Network Bus Protocol, that is called CAN bus protocol. Here the dashboard is connected through the CAN bus with a different speed. So it basically classified into two speed: low speed CAN bus and high speed CAN bus. In low speed CAN bus, the power, like very rare power seats, power windows, lighting, that will be connected with the low speed CAN bus. The high speed CAN bus will be connected to that important, like transmission control, anti-lock brake system, that is called ABS, braking system, and then suspension mainly on engine control. These are the controllers are connected to the dashboard through high speed CAN bus. So it has three types of CAN bus are identified. One will be the low speed, that will be 128 kilobits per second. It has the identification of 11 bit identifier. Next will be the method. Next type will be the standard CAN 2.0, that will be 1 Mbps, 1 megabits per second. It's also 11 bit identifier. Then extended CAN 2.0B means it have 1 Mbps, but the 29 bit identifiers. So if the number of bits identifiers increase, you can identify more number of devices inside the automobile. So I already said it will be different category in the CAN according to the speed. The low speed will be the 125 kbs. That means it covers only 500 meters. So that whenever the speed will be low, it will be cover long distance. That is called 500 meter. If the speed is high in the CAN bus, that means 1 Mbps. Then means the number of distance covered will only the 40 meter. If you want more than 1 Mbps, 15 Mbps, the length of the data transmission is again reduced into 10 meter. So yeah, lower speed CAN is used to connect the door lock, seat control, and climate control. For body electronics, we can use the low speed controller. So the main parts of an CAN bus, or it has a CAN controller. The CAN controller will connect the microcontroller and the CAN transceiver. CAN transceiver means transmitter and receiver. So the CAN receiver will receive the data from the devices and send to the microcontroller. The microcontroller will give the done the operation. Then the results will be given to the actions will be given to the devices through the CAN controller, the through CAN receiver. Right? So here also we have two buses, hand high and hand low. You are connecting two different speed of devices inside the automobiles. So a microcontroller will decide the what message to transmit among the devices. The CAN controller will ensure the connections between the controller and the devices. The CAN receiver will receive and transmit the data. So I already said each CAN node has the host, that CAN controller, CAN receiver. So in microcontroller we have a CAN controller, CAN receiver. Similarly, in the every device inside the automobile, it has having the CAN controller and CAN receiver. So each device can be connected to the CAN high or CAN low according to the speed you need. Here the transmission, the RT is the termination to end of the communication, to indicate the termination of the communication, RT. Here the bus connected different nodes. So for example, CAN node will send the data, means it will prepare the data and send the data to through the CAN bus. If the node and 2 and 3 all the nodes are receive the data, but which one needs the data, or which the data consists of which identifier will receive the data, check the data, that the concerned node will accept the data, the remaining nodes will ignore the data. That's why the communication will be occurring, which is I already explained. The microcontroller will decide the which data going to be transmitted or received through the devices through CAN receiver. So this is the message framework used in the CAN bus. Have the starting frame. Starting frame, it has the one which indicates the starting of the message frame. This message identifier is used to identify the device, which device you to connect the connected to or to transfer the data. That message identifier is simply noted as the address of the device which is connected to the microcontroller through CAN bus. Then controller, we need the what are the control signals you are able to transfer. Then we can send the data up to 64 bits. Then finally, after the data, we have a CRC. CRC means cyclic redundancy check. That means you have to detect the error checking codes. That is called like parity bit. If there is any data will be missing the during transmission, you can check through the CRC. Finally, the acknowledgement bit also sent in the frame. The end of the frame will be denoted by EF. This is a one single frame for transmitting a data from microcontroller to the devices. So not only the applications of CAN bus not only restricted to the automobiles, it is also in healthcare, elevators, controllers, and military defense systems. Then we have a large machinery industries. We have large of machinery. We can use the CAN bus. In submarine also we can use the CAN bus. Thank you.